Hello everyone, welcome to yet another video of measurement and instrumentation. In this video, we're going to see a continuation of the previous topic. So in last class, we have discussed about ammeters and voltmeters, and we have ended the topic with types of instruments. So in this topic, we are going to have a continuation of the previous topic. So in last topic we have seen the types of instrument used for voltmeter and ammeters, and as I already told, PMMC is the most commonly used type of voltmeter and ammeter, and along which we are also using moving iron type. So now let's see what is moving coil instruments. So moving coil instruments are of two types. One is permanent magnet moving coil type, the other one is dynamometer type. So this PMMC, permanent magnet moving coil type, is used only for DC measurements, whereas dynamometer type is used for both AC and DC. So in this video we are going to discuss only about the PMMC. The rest will be discussed in the upcoming videos. So PMMC, permanent magnet moving coil instruments, are also called as de-Arson-Valve instruments, as it is named behind its inventor. So these instruments works on electromagnetic effect of current, which is the basic principle behind a motor. So a PMMC instrument and also a motor works with the same principle, and the setup will also be very similar to a motor. A permanent magnet is used to produce the magnetic flux, and a coil is being placed in between the permanent magnet so as to move the pointer. So let's see the working principle. So it works on the principle of electromagnetic induction. So as per the law, when a current carrying conductor is placed in a magnetic field, it experiences a force of value BIL, where B is the flux density, I is the current, and L is the length. So when the current I, which is to be measured, is passed through the moving coil, which is placed in between the permanent magnets, it experiences a force which is directly proportional to that of current. And due to this force, a deflection torque is being created in the coil, and this torque is being transferred to the pointer which is attached to it. So the pointer will start moving across the scale. The angle through which the pointer moves is proportional to the amount of current. So this diagram shows the construction of the permanent magnet moving coil instrument. So it has a core, and above the core the coil is being mounted with the help of an aluminum former, and the aluminum former setup is attached to a spindle, wherein which the pointer is being attached with a pivoted jewel bearing so as to provide stability. And also the coil is placed in between a permanent magnet. So a counterweight or a balancing weight is provided at one end of the pointer so as to provide the controlling torque. And a spring is also attached to the pointer so as to bring the pointer to its original position after showing the necessary readings. And also the pointer moves over the scale, which is of a mirror type. So from the expression we know that the deflection torque is proportional to the current, and therefore TD is proportional to I, and the controlling torque is proportional to the angle of deflection. In steady state, this TD is equal to TC. Therefore, the deflection will be proportional to the amount of current measured. Let us see few advantages of PMMC. So PMMC consumes less power and it has greater accuracy, and it has a uniformly divided scale, and the pointer can move up to 270 degrees Celsius. And also the PMMC instruments have high torque to weight ratio, and the same PMMC instrument can be used as ammeter and voltmeter with adding suitable amount of resistance, which is a bigger advantages of having a PMMC, because a same setup can be used as ammeter and voltmeter. It provides efficient damping and it has no hysteresis losses. The disadvantage is that it can be used only to measure DC, because the reversal of current produces reversal of torque of the coil, and the PMMC is very delicate and sometimes uses AC circuit with a rectifier. So if you use in an AC circuit, it will act as a rectifier. And the most important thing is it is very costly compared to the moving iron instruments, and also it shows some error because the permanent magnet will lose its magnetic property as the days prolong. Now let's see how the same PMMC can be used as ammeter and voltmeter. So if you want to use an ammeter, a PMMC as an ammeter, you have to connect in series with the load, and also an additional extra shunt resistance is to be added along with the PMMC instrument. If you want to convert the same meter to a voltmeter, you have to connect a series resistance to the permanent magnet moving coil instrument, and together they have to be connected in parallel to the load. So this is how you can use the same PMMC as ammeter and voltmeter. So by adding these external resistance, it will not alter the measuring property or the stable operating conditions of the entire instrument. So with this we have come to the end of this video. In the next video we will see the other type of moving coil instrument. Thank you. Thanks for listening.